Hi students, today we are going to see the topic on ultrasonic testing. I am Sathish, Assistant Professor Mechanical Engineering Department at Akshay College of Engineering and Technology. Ultrasonic testing, high frequency sound energy is used to identify surface and subsurface discontinuities. Ultrasonic detects equipments makes it possible to locate defects in all types of material. Minute crack, checks and voids too small to be seen by X-rays can be located by ultrasonic inspection. An ultrasonic testing instrument requires access to only one surface of the material to be inspected and can be used with either straight line or angled beam testing equipment. Principle: whatever there is a change in the medium, the ultrasonic waves are reflected. Thus forms the intensity of the reflected echoes. The flaws are detected without destroying the material. Types of ultrasonic wave: longitudinal wave, transverse wave, surface or Rayleigh wave, lamp or plate wave. Wave type: particle vibration. Longitudinal wave travels the fastest of the wave mode and are commonly used in ultrasonic testing method. In longitudinal wave, particle motion in the medium is parallel to the direction of the wave front. Transverse or shear wave. They are used for most angled beam testing in ultrasonic flaw detection. Shear waves have a slower velocity and shorter wavelength than longitudinal wave of the same frequency. Surface or Rayleigh wave. Surface wave can be used to detect surface breaking cracks in a test piece. Surface wave, also known as Rayleigh wave, represent an oscillating motion that travels along the surface of a test piece to a depth of one wavelength. Plate wave or lamp wave. Lamp wave or surface wave propagate parallel to the test surface and have a particle motion that is elliptical. They occur when the thickness of the test material is only a few wavelength at test frequency and where the test piece is of uniform thickness. Two basic methods of used for ultrasonic inspection. The first of this method is immersion testing. In this method of inspection, the part under examination and the search unit are totally immersed in a liquid coolant, which may be water or any other suitable fluid. The second method is called contact testing, which is readily adapted to field use and is the method discussed in this chapter. In this method, the part under examination and the search unit are coupled with a viscous material, liquid or a paste, which wets both the face of the search unit and the material under the examination. There are three basic ultrasonic inspection methods: pulse echo, through transmission, resonance. Equipment and transducer. Piezoelectric transducer. The conversion of electrical pulse to mechanical vibration and the conversion of returned mechanical vibrations back into electrical energy is the basics of ultrasonic testing. This conversion is done by a transducer using a piece of piezoelectric material, a polarized material having some part of a molecular positively charged while other part of the molecular are negatively charged, with electrodes attached to two of its opposite faces. When an electric field is applied across the material, the polarized molecules will align themselves with the electric field, caused the material to change dimensions. In addition, a permanently polarized material such as quartz or barium titanate will produce an electric field when the material changes direction as the result of an imposed mechanical force. This phenomena is known as piezoelectric effect. Transducer type. Transducer classified into two major groups: contact transducer, immersion transducer. Couplant. A couplant is a material, usually liquid, that facilitates the transmission of ultrasonic energy from the transducer into the test specimen. Couplant is generally necessary because the acoustic impedance mismatch between air and solid is large. Therefore, nearly all of the energy is reflected and very little is transmitted into the test material. The couplant displaces the air and make it possible to get more sound energy into the test specimen so that an unstable ultrasonic signal can be obtained. In contact ultrasonic testing, a thin film of oil, glycerin or water is typically used between the transducer and the test surface. When shear wave are to be transmitted, the fluid is generally selected to have a sufficient viscosity. Some couplants are water, oil, glycerin, petroleum grease, silicon grease, wallpaper paste. Pulse echo technique. Ultrasonic pulse receiver as well suited to generate purpose ultrasonic testing. Along with appropriate transducer and an oscilloscope, they can be used for flaw detection and thickness gauging in a wider variety of metal, plastic, ceramic and composites. Ultrasonic pulse receivers provides a unique low-cost ultrasonic measurement capabilities. Data presentation. Ultrasonic data can be collected and displayed in a number of different formats. The three most common formats are known in the NDT world as A scan, B scan, C scan. Presentation. A scan. A scan presentation displays the amount of received ultrasonic energy as a function of time. The relative amount of received energy is plotted along the vertical axis and the elapsed time, which may be related to the traveled distance within the material, is displayed along the horizontal axis. B scan. It is possible for automated linear scanning system which is shown a profile cross-sectional view of the test specimen. In the B scan, the time of flight, travel time of the sound wave is displayed along the vertical axis and the linear position of the transducer is displayed along the horizontal axis. From a B scan, the depth of the reflector and its approximate linear dimensions in the scan direction can be determined. The B-type scan is typically produced by establishing a triggered gate on the A scan. C scan. The C scan presentation is a type of presentation that is possible for automated two-dimensional scanning system that provides a plane type view of the location and size of the test specimen features. The plane of the image is parallel to the scan pattern of the transducer. C-scan presentation are typically produced with an automated data acquisition system such as computer controlled immersion scanning system. In this picture we can able to see A-type scan representation and B-type scan representation of the images which it is propagating in the slide. Time and the signal strength is varied in the A-type scan. In the B-type scan, scan distance and the time depth which shows in a linear wave. In the below image, we can able to see the scan pattern of the top view and side view. Welding defects. By using the ultrasonic testing, we can able to see the weld defects of porosity, cracks, slacks, inclusion, undercutting, longitudinal or transverse cracks, etc. Application of ultrasonic testing. Quality control and material inspection. Detection of failure of rolling socket axis, pressure column, earth moving equipment, mill rollers, mixing equipment. Measurement of metal section thickness. Thickness measurement. Refinery and chemical processing equipment, submarine hulls, aircraft section, pressure vessel, etc. Inspect pipe and plate welds. Inspect pins, bolts and shafts for cracks. Detect internal corrosion. Advantages of ultrasonic testing. Sensitive to surface and subsurface discontinuous. Superior depth of penetration for flaw detection. High accuracy. Position, size and shape of defect. Minimal part preparation. Limitation of ultrasonic testing. Surface accessibility for ultrasonic transmission. High skilled and trained manpower. Irregular, rough, coarse grained or non-homogeneous part. Linear defects oriented parallel to the beam cannot be inspected. Low transmission and high noises. Coupling medium required. Thank you. Thanks for listening, students. Thank you.